Hi everyone, this video is an exercise 11G question 5. So we have f of x, and in part A we want to basically write f of x as partial fractions. Okay, so since the highest power of the numerator is the same as the denominator, then we need to use long division, and so we have 9x squared. So 9x squared minus plus 4 divided by, so we always divide the numerator by denominator if the highest power of the numerator is greater or equal to the highest power of the denominator. So 9x squared plus 4 divided by 9x squared minus 4. And okay, so at first we just have only one, so we have 9x squared minus 4, and now we subtract, so we get 8. Now that means that in terms of the partial fractions, so we'll have 9x squared plus 4 over 9x squared minus 4 is equal to, so now we can write down the quotient, which is this number here, plus the denominator over the divisor. And this part, 8 over 9x squared minus 4, is the part that can be written as partial fractions. So now remember that. So we can basically write 9x squared minus 4. When we factorize, we'll get 3x squared minus 2 times 3x squared plus 2, which is essentially equivalent to b over 3x squared. I'm sorry, actually, when we factorize, we won't have this as square term, just 3x minus 2 and then 3x plus 2. So b is over 3x minus 2, and then c 3x plus 2. Okay, now at this point we just multiply both sides by this denominator, the denominator of the fraction on the left hand side, and we'll have 8 is equal to b times 3x plus 2 plus c times 3x minus 2. And now at this point we can just set different values of x such that one of the brackets is going to be equal to 0, and then we can solve that. So first, let x be equal to minus 2 over 3. Then that gives us left hand side is just 8, and the right hand side is going to be minus 4c, which means c is equal to minus 2. Then let x be equal to 2 over 3, because that makes the second bracket equal to 0. So we have 8 is equal to 4b this time, and b is equal to 2. And now so remember that we wanted to integrate 9x squared plus 4 over 9x squared minus 4, and we already had 1 from the long division, and then these two fractions that we have found are also going to be included instead of 8 over 9x squared minus 4. So that means the integral, because we need to integrate that between the minus 1 over 3 and 1 over 3. So it will become 1 over 3 minus 1 over 3, and then 1 plus 2 over 3x minus 2 minus 2 over 3x plus 2 dx. Okay, now we have some simple integration. So 1 integrates to x, and then this part, so we can start with the guess of ln 3x minus 2, but this obviously gives us 3 over 3x minus 2. So but we want to have 2 above, so we just need to add this constant of 2 over 3 outside, so that cancels out. And then for this part, so let's say we have minus ln 3x plus 2, but that's just the same thing, so minus 2 over 3, because minus 2 over 3 times 3 is just minus 2, and then we'll get the same thing as here, and obviously the limits. Okay, so for simpler calculation, it's better to simplify inside, or actually we can even continue without simplifying, so it won't be a big deal because we have 1 over 3, so yeah, it's not too bad. So first, let's see if they have asked for a specific form. Yeah, they want the answer to be in the form a plus b ln c. Okay, so let's substitute a third. We'll have a third here plus 2 over 3 ln So inside it will be -1, but that just basically len 1. And then -2/3 len, so 1/3 substituted will give 3 from inside. And then now -1/3 substituted, so -1/3 plus 2/3 len. So -1/3 here will gives us -3, but since it's modulus, it just becomes len 3. And -2/3 len, so again -1/3 substituted, is going to give us basically -1 plus and just 1. So now the first bracket is 1/3. So remember len 1 is 0, so this term is just 0, and then -2/3 len 3. And then for the second bracket, so we have minus third, which is 1/3, and then -2/3 len 3, but the last term is again 0 because we have len 1. And at this point, we get 2/3 minus 4/3 len 3.